All right, so let's look at number 17. Now, guys, here's the deal. Starting this week, probably Wednesday or Thursday, we're going to get to something called unit conversions. And every year, this is probably one of the most challenging things we do because you're not used to it. You've never seen it before, and it takes you a little while to grasp onto how to do it. So here's what I always do. I always show you the hardest possible problem. Today, you're going to see as hard as it can possibly get. So the good news is that if you get this today, the rest of the stuff we do is going to be a breeze. Okay? And I teach that way sometimes. I show you the hard stuff first, so when we get to it, the easy stuff is really, really easy. So if you don't get it for some reason today, at least get one piece out of it. Understand why we did one of the things that we're going to do, and I'll pull you along for the rest of it. Okay? So question 17. It says at a cost of $1,200 an ounce. Now I actually need you to help me out. I want you to change this number, and I actually need to do this because I forgot what the number was. We're going to change that to make it more accurate for today's value. Price of gold $1326.60. Well, there you go. Liquid ammonia. Hang on. 13. He was talking about something different. So it's $1,326.60. That is actually market price of gold today. That's what I just looked up. I want to make it accurate for today. Okay? So at a cost of $1,326.66 per ounce, how much would you have to pay for a solid cubic foot of gold? Now, what is always my first question? What's the question? What's the question? What are they asking you to solve for? Have to pay. Now, you know this. Your final answer must have a unit of what? Dollars. We got to get this thing to dollars. Now, luckily, is there a dollar anywhere in our question and our data? There is. We got to manipulate how we can get it there to the very, very, very end. Now, I'm going to go ahead and tell you this. This cube that I have in my hand, okay? It's 11 by 11 by 11, so it's almost a cubic foot, right? So 1 inch all the way around added to it, that would be a solid cubic foot. If this were a cubic foot of gold, could I hold it like this? Okay. In a minute after we do this problem, we're going to change one little part of it, and you're going to find out how much it actually would weigh in pounds. So that's one of the cool things. You're going to get to see that. Okay? So you'll find out how much it would weigh versus how much it would cost. So here's the deal. Ignore the useful information for a second. We don't need that. We're going to get to that in just a second. So if you read it again, we have two pieces of data. Would you agree? The two pieces of data are the price per ounce and the volume. How do you know that this is a volume? Cubic foot. Very good. So do me a favor. Write volume underneath that. Now, I ask this question every year, and students kind of struggle with it. Both of these things are what we call derived units. And what I mean by derived units is how did they get the cubic foot? What do they have to do? Length times width times height. That's how they got the cubic foot. And then the price per ounce is just something that we can deal with in just a second. And students always struggle with, well, which one do I use to start with? Okay. Well, let me ask you something. I'm going to come over here. Don't write any of this down. Just kind of stay with me. It's $1,326.60 per ounce or 1 cubic foot. If I had to start with a unit, which one's going to be a lot easier to start with? The one with 2 units or 1? One's a lot easier than 2, right? Because do you agree up here, I've got dollars and ounces I would have to deal with. Down here, what do I have? Cubic foot, that's it. Okay. So let's start there. And this is why I said this is the hardest problem. It's going to get easier than this. Okay? Don't worry about the difficulty level. So we're going to start with 1 cubic foot. Now, this is something I hope that you guys know. Mathematically, let's set it up just like this. And we're going to be using these parentheses like this for a long time. We'll be using them the rest of the year. So go ahead and get used to doing them. If I need to mathematically cancel cubic foot, where do I put it? On the bottom. Would you agree with that? Now here's the problem. I've got to get all the way to dollar bills. So let's look at that useful information for just a second. So I've got 1 ounce equals 28.4 grams, and I've got 1 inch equals 2.54 centimeters. So here's my question. If I need to get rid of cubic feet to get to dollar bills, what do you think the next unit I can use in the stuff that's given would be helpful? Inches. Now, here's where students mess up. And again, I'm saying this again. This is as hard as it gets. It gets easier. Look at your units. Can you go from a cubic foot to an inch? Cubic inches. Does that make sense? Now, here's the part, again, that students struggle with. Do you know the relationship between inches and feet? Just inches and feet. Okay? Where's the 1? 1 foot is 12 inches. But here's the problem. That's for the ruler. How many rulers? That's 1 ruler. How many rulers did you need to measure this thing? 3 of them. So what do you think we have to do to those values? Let's cube them. Again, if that confuses you, just hold on. We'll come back to it. Now, here's an easy question. What's 1 cubed? What's 1 times 1 times 1? Every year. 1 cubed is 1. What is 1 to the 100th power? Thank you. All right. So now, this is canceled, and this is canceled. True or false? Now, again, you've already told me my answer unit must be a what? A dollar sign. Do I have to keep going? Yep. Okay, I can't stop here. Now, here's the way that I teach this. You may not have a clue what to do next, but at a minimum, do you have to get rid of cubic inches? Then where must it go to get rid of it? It's got to go on the bottom. Cubic inches. Now again, let me say that one more time. Why did I put it on the bottom? To cancel it. Go ahead. Yes, hold that next though. We're coming there. So here's the deal. I just said you may not have a clue where you're going, but at least this has to be true. Now, Ralston, you just said the next thing I need to go to is cubic centimeters. Okay, this is going to be helpful to us, right? So let's go ahead and let's add this here. Now, Ralston, you said something very important, and this is the step that I just kind of want to ask. Why are we still cubing this thing? It's still a cube, right? Is it still a volume? Okay, all right. Now, here's the deal. I'm just curious. Did anybody already know that 1 inch is 2.54 centimeters? Anybody know that? If you did, awesome. I'm impressed. So, we already know that in 1 inch, there are 2.54 centimeters. But that's just for 1 ruler. How many rulers did we need for this cube? 3 of them. So what do we do for these values? Cube it. So we're going to cube that. We're going to cube that. Now, what's 1 cubed? 1. This next step is where every year people just kind of stare at me with that side puppy dog look face that you are so confused. But stay with me. It'll all come together in the end, I promise. First of all, did those 2 things cancel? Okay? You may not have a clue where you're going, but why can I not stop right here and give you an answer? What am I looking for? Dollars. I'm not in dollars yet. So what I need is one more step. You may not have a clue where you're going, but where do you have to put cubic centimeters? Got to put it on the bottom. Hang on, Ralston. Again, this is the step where everyone kind of looks at me real funny, and I'm going to help you out. I'm going to give you a guide. Now, Now I know what you're thinking. How in the world, don't say anything out loud, let everyone kind of absorb this. How in the world did you go from cubic centimeters to grams? Hang on, don't say anything out loud. Here's my first question. God bless. Grams is what type of measurement? A mass. Cubic centimeters is what type of measurement? Volume. So let's look at that. Mass over volume. Huh. That sounds familiar. What is mass over volume? Amazing. Density. Now, we just did this. Does every substance have its own specific density? What is this big, huge cube made out of? Gold. Now, you don't have to memorize the density of gold because if you flip your sheet over, is there gold still there? Yes. Now, here's the part where students get confused. On that sheet, it is written like this. 19.3 grams per, 19.3, my apologies, 19.3 grams per milliliter. This is the part where I hope it all comes back to you. Doesn't a cubic centimeter also equal a milliliter? So is this appropriate? Now, where does this number now go? The way we read density is 19.3 what? How do you say it? Grams per cubic centimeter or milliliter. Now, when it says per, now no, we're not talking about kitty noises, okay? Per milliliter. So that means for every 1 milliliter or cubic centimeter, how many grams are in it? Yeah, I'll do it that way. So 1 is 19.3. This is the step every year that kind of throws people for a loop, but does it make sense? And I know what you're sitting there thinking. If I had to do this on my own, I couldn't do this. You're right. You couldn't. I've never taught you this. I don't expect you to be able to do it. All I'm wanting you to understand is a few things. Number one is, why are we putting units on top and bottom? We're canceling them out. And number two, do you kind of understand the flow of how this goes? Okay? Now, my next question is, do cubic centimeters cancel? Yes, and I keep asking the same questions if you notice. Why can you not stop and give me an answer? What am I looking for? Dollar bills. Okay, so I've got to go one more step. Now, this is the one that most people know. If I got to get rid of grams, where does it have to go? It's got to go on the bottom. So, remember, we're trying to get to dollars, and we see grams, and now if you notice, we have this thing right here. We've got these two things right here. We've got dollars attached to ounces, and we've got grams attached to ounce. So do you think there has to be a connection from grams to dollars? But who's in the middle? Ounces. So we need to go from grams to what first? Ounces. Fantastic. I will never, ever, ever require you to memorize any of these conversion factors. Will you slowly begin to memorize some of them? Yes, because we'll use them so much. But this sheet right here, I know you can't see it. You will get one of these this week. You will be able to use this on your test. I do not require you to memorize measurements because I don't even know. Okay, so you will get to use this. So don't worry about having to know all of them. Now, we know that, and this is the cool part, it tells us that in 1 ounce, it is 28.4 grams. Does that make sense? Okay. Now, what happens to your unit of grams? What happens to it? It cancels, leaving us with what? For the 4th time, why can't you stop and give me an answer? What are we looking for? Money. I have no idea where I'm going, but I at least know this is true. If ounce is on top and I have to get rid of it, where must it go? It's got to go on the bottom. And here's the best news of the day. Is there a way for me to go from ounces to money? Yes, that's the best news. So, we know, now I'm going to write it over here. Well, no, I'm just going to write it right there. Okay? So, now's when we need this thing. So, in 1 ounce, 1,326 and 60 cents. Okay? Now, we know that ounces cancel. And what are we left with? Dollar bills, y'all, right? Okay, so we can now run this in our calculator. But before you do this, explaining what? Because I started with a cubic foot, and I have to incorporate all of this into that. Because if you're at, think about it from this perspective. Can you go from 1 cubic foot to ounces? You can't do that because will your units cancel? No. And that's why it takes this process. So let me say this again. This is as hard as it gets. If you followed this, you are well on your way to being really successful. If it kind of is hard for you, it gets easier than this. That's the best news. Ralston? You are absolutely right in that, but I do not want to go above that because it tells you right here. But yes, what you are saying is absolutely correct. And I want to say this out loud for some of you that understands what he is saying. That in this part right here, you can actually flip this relationship that in 1 gram there are so many ounces. And as a matter of fact, it's not on this sheet, and so that would be something you would actually have to look up, and I don't know what it is. But that's what you could do that if you wanted to, yes, to make it easier. But we are going to leave it like this just because I want to see if your calculator skills are good enough to figure this out. Okay. Now, before you plug this in your calculator, I need to make sure you understand one thing. Follow the yellow highlighter circle. Those two numbers, when you plug them in, what must you do to them? You have to cube them. Now, as far as all of the values other than 1 that are on top, what do? Multiply. And what are you going to do with the non-one value number on the bottom? Divide. See if you can calculate the answer here. This is where I'm testing your calculator skills. You've got the setup. I just want to see if you can actually plug it in. And please don't say it out loud yet. Let everyone have an opportunity to see if they can plug it in. I'll come around and kind of just make sure you're... Yeah. Okay. What that is actually the better way to do it. But we didn't have that relationship, and I didn't have that memorized, so we have to use this. All right, so I'm going to pull up the calculator, and I'm going to show you guys how I would have done this. Let's see. I may need your help in doing this. So on, clear. Now, why do we not need to worry about the 1 cubic foot? It's just 1. We don't need that, okay? So I'm going to do 12, and I'm going to cube it, times 2.54 cubed. Now, the next one is 19.3. At this point, if you wanted to hit equals and divide by the bottom value, that 28 point whatever, you are more than welcome to do that. But I'm going to continue multiplying, and I'm going to divide at the end. So times 1326.60, and that is my entire numerator. That's all of my numerator values multiplied together, and I'm going to divide by the 1 denominator that's a non-1, and it was 28.3 or 4. 0.4, okay? And that should be my answer. Oh, I looked at the first two numbers. Yours was 25 point, or 25 what? Oh, see, I saw the 25 and just quit looking. My bad. Now, here's how you would need to write this in significant figures. 25 million. $25 million. What it costs you to own a solid cubic foot of gold, sir. Have y'all seen the previews for the new movie coming out with Matthew McConaughey in it? It's about a gold. I think it's called Gold, actually. But he goes down into the Brazilian rainforest and finds a gold mine. I think it may be a little. No, it's brand new. They may be redoing it, but it's a brand new movie. It seems very rough and gruff, kind of like Wolf of Wall Street, but I think it may be like a cool movie, though. Yes, sir. Actually, you know what? Cody asked a really good question, and I want to bring this up because I think it's important to understand. Now, it's not going to. It will change your answer, but it's not going to change the concept of all of it. And here's what Cody asked, and I really think it's a good question. He said, "What if it was not 1 cubic foot of gold? What if it were 3 cubic foot of gold?" That's a really big box, right? But what would be the only thing that you would have to do different? This 1 would have to change to a what? A 3. So you could multiply your answer times 3, and that would give you the final answer. No, because you've already divided. You just multiply, you just triple it. Does that make sense? But initially, instead of just doing all of the stuff over there, you would have to incorporate the 3 in the multiplication. Real quick, I know we're running out of time, but I want to show you how much this thing would weigh. It's a really simple change. First of all, we're trying to get to pounds, right? So do I need this money thing anymore? No, I'm going to get rid of it. Okay? And there is actually a conversion from grams to pounds. So LBS, and there are 453 grams in 1 pound. Stay with me. Stay with me. Stay with me, guys. All right. Do y'all want to know? 12 cubed times 2.54 cubed times 19.3. Nope, that's 0.6. Divided by 453. It weighed 1,206 pounds. No. You could have went from grams to ounces and ounces to pounds. You could have done that, but there is a direct conversion right from grams right into pounds. So it would be kind of like, in a simplistic way, if I need to go from inches to yards, you can go 12 inches to 1 foot, 3 feet to 1 yard. Or you can go 36 inches to 1 yard. Same thing, just an easier way to approach it. Yes, ma'am.